This tutorial will demonstrate how to use Geometer Sketchpad in order to help your student understand the connection between the slope of a tangent line of sine and the derivative of sine. We are using Geometer Sketchpad 5. To get our initial sine curve, we go to Graph, Plot New Function, and then under the Functions tab we get Sine, and do sine of x, press OK, and then click yes that we want to do this in radians, as that's most useful for our sine curves. We now have our sine curve plotted. Note that there are 2 points on the x and y axis. These act as movers for the 2 axes so that you can stretch along the x-axis. Note that the radians show up in smaller degrees when you do this, or along the y-axis. This can be very helpful if you want to change the period that you're looking at over the sine curve. So to find the tangent, we're going to use the line segment button, only we want to change this to a line, so hold that down and select the one that has lines on 2 ends. As you know, any line is defined by 2 points, so we want to have 2 points on our sine curve. Note that when you click a point near the sine curve, it is highlighted. Make sure that both points highlight. We want to see the tangent line, which is not a very good approximation when the points are far apart. However, as the 2 points move closer together, we get a very close approximation of the tangent line. To label these 2 points, select them, press alpha, click on them again, so we can label them A and B so they're easier to recognize. Let's keep our 2 points fairly close together so we get a good approximation of the tangent line. To find the slope of this tangent line, or tangent line approximation, we select the line and go under Measure Slope. Note that it's given as the slope of AB, as our line is defined by the 2 points A and B. If we want to see how the line's slope is affected as the points move along the sine curve, we select the line and go under Display, Animate Line. As you can see, the slope alters as it moves along the sine curve. The motion controller here allows you to change the speed here, so you can make it slower or faster. Or you can pause at any point, or stop the animation altogether. 1 is usually a good speed to use for this. Now, if we want to plot the slope of a line, a sine curve, we will use our slope here and also the x-coordinate of one of our points. We'll choose point A. To find the x-coordinate, go to Measure Abscissa of x, and that gives you the x-coordinate of A. Note that if you move the line, the slope and the x-coordinate of A will change. In order to plot the slope of the sine curve for each x value, we will plot the x, y using x of A, or abscissa of A, and as our x-coordinate, and the slope of AB, which is our sine curve, which is our tangent to the sine curve, as our y value. So we select these two, go under Graph, Plot as xy. Note that the point here is graphing the slope of the sine curve for each x value. Now, if you'll reanimate your line, you see that the point plotting the slope moves along with our line. But this doesn't give us a very clear idea of what's happening as this goes along. We would like to graph this point. Before we plot the graph of this point, let's move our graph back a little bit so we can start over here. To do that, press this button, and the tangent line will animate in reverse. That's probably a good point. We'll stop here. To plot the function of this graph, highlight only this point, and then go under Display, Trace Plotted Point. We'll resume our animation of the line by selecting the line and then going into Motion Controller and pressing play. As you note, the slope is being plotted in orange. as the line moves along the sine curve. As you can see, I've let the program run so that the slope is plotted all the way along the sine curve. Note that it's a little bit off between this line and this line. You can sort of see a double plotted trace line. That's because there is a slight difference between these two lines. Again, this is only an approximation of the slope of the tangent. In order to have this as a program, if you wanted your students to just open it, you can animate this point and have an action button, which will allow students to watch this happen without this motion controller box. In order to do that, let's go ahead and erase our trace that we've just created. To do that, go to Display, Erase Traces, the orange line disappears. Next, we'll select these 2 points and go to Edit, Action Buttons, Animation, and we'd like both of them to be at the same speed so they move along together, so click OK. Now when you click this point, it will animate the 2 points, and the trace will still appear as the lines move along. And then when you press the button again, it stops. This is very useful if you would like your students to open this program on their own. Once you have traced the line along the sine curve, it will be useful to ask your students to note what this plot looks like to them, what other function they can think of that matches this plot. Hopefully they'll note that it looks like the cosine curve, and you can bring into this the fact that the derivative of sine is the cosine curve, and that derivatives are plots slope of the tangent at each point along the graph. If you wanted to double check this, you could always go to Graph, Plot New Function, and then instead of sine, do a cosine curve this time. And it would fit roughly along your trace line, depending on how close your points were together. Again, it's just an approximation. But this is a great program to help your students see the actual movement of the tangent line. Thanks, I hope this helped you out.